values over. So we still have this issue of, well, what about 7? How are we going to estimate 7? But what we do is, in this bucket, we also store this extra piece of information. So it's this piece of information. There are 2,098 values in this bucket. That's just normal histogram information. This is the extra piece, 1213, which says somewhere between here and here, we have number 7. We have 2,098 in this bucket, but 1,213 of them are the last value of 8 of archive. So we know that 7 and 8 must sit in here. We know that 2,098 of them are the whole bucket, and 1,213, this new piece of information, is the value of 8 of archived. So if there was 2 or 3 values in here, like I should have put some more values in, like 6.5, 7.5, then they would all swell up to 2,098 minus 1,213, because 8 is exactly 1,213. So let's look at some mathematics. Bucket of 8 has 2,098 occurrences. 1,213 of them are this specific value. Therefore, there are 885 values left that are greater than the previous bucket and less than 8. And that's how we do an estimate for 7. The cool thing with that is nothing ever spans a bucket anymore. You'll never see 8 of archive in multiple buckets. There's no bucket spanning anymore. And here's a key point. As I mentioned, you only get hybrid histograms if you're using auto sample size. If you're doing sample size 100, sample size 10, sample size 1, all those things, you don't get this. You have to use auto sample size. So important. And this is actually true for 11 as well. There's only one sample size you should ever use, and that's auto sample size. You still need some care. So I'll pause at this moment and say, hopefully I've convinced you that histograms have been really radically improved in 12C, 18 and 19. We've ditched high balance histograms. You simply won't see them unless you've upgraded and they're still there. We'll go frequency, if possible. If we can't go frequency, we'll go top frequency, which is still pretty good. And if we can't go those two, we'll go hybrid, which is still much, much better than high balance. So histograms are much, much better in 12 and onwards. Having said all that, it doesn't matter how good your histograms are if you're collecting them for the wrong data. What do I mean by that? You have to use representative values. Who's heard of these things called Black Fridays and Cyber Mondays and Electronic Tuesdays and all these silly things where one day of the year you can just spend every piece of money you've got on a gadget you don't need? That's what I do once a year. I was like, oh, I need a new phone because this phone is like, it's 3 months old. Oh, it's so bad. I need a new phone. Yeah. I spend stupid amounts of money on stuff I don't need because I get sucked in by this kind of stuff. Every time we have these Black Friday deals or whatever, this is the big thing that's all over your website. Come and click on today's hot deals. And this is what we do as DBAs. Normally this reads, say, 3 a.m. and 4 a.m. in the morning, maybe, when everything's really quiet. That's when we gather stats, because we don't want to gather stats during the day because it would impact our machines. Most of us use that or use the default, which is 10 till 2 in the morning, but we use it on quiet hours. Between 3 and 4 in the mornings, nothing I want to sell has been tagged as being a hot deal. And then at 5 a.m., I'm about to launch the Black Friday. I'm going to activate those hot deals. I'll update some of my items and set them to being a hot deal. And now I've got 14 items that are a hot deal. They're the 14 things that I'm going to give these 90% discounts on, etc. And of course, then on your biggest day of the year, when your website is absolutely busiest, every single query that anyone is running on your website, what's the predicate going to be? That. Everyone's clicking on the hot deals. You know the next thing happens? Your server goes up in smoke. And the reason for that is, this is the query that everyone's running. When you gathered histograms and gathered stats in your tables, it just didn't exist. Because you gathered stats at 3 in the morning. How does the database optimize something that it doesn't even know about? There is no row called hot deal of 0. Yeah, if I do a count star, I don't get rows for values that don't exist. There is no row for hot deal. Because when I gathered stats, I didn't know there were hot deals. There were none at 3 in the morning. They came into existence later. So that's what the stats look like somewhere in the database. Normally, this is how the optimizer works. It says I've got a million rows, 7 distinct values, there's 4 popular ones and a frequency histogram that add up to 910,000. 3 values left to cover the rest. We use what's called a density calculation. 3 values left over 90,000 rows. That's a calculation called the density, which is critical to the optimizer. You're done. And you can actually see it. We have the number of rows, the number of popular rows, etc. But if I don't have a histogram on hot deals, the number of popular rows, the total number of rows, is the same as the number of popular rows. Because I have a frequency histogram for every single item because there were no hot deals. So when my calculation comes in, number of distinct values on that minus that, computers aren't fans of dividing by 0. You can't divide by 0. And the optimizer panics. So when you do a query for type of hot deal, instead of being 14, it gets 2,107. Now where on earth did it get that from? This is the information it knew about. It picked the lowest one and divided by 2. And that's just merged into the optimizer. If you present me a value I have no idea about, I've never seen what a hot deal is, and I have nothing about it, it picks the smallest one and divides by 2 and says, that'll do. That's the best I can do. Because it has no idea. So it doesn't matter how good your histograms are, if you gather them at the wrong time, you're going to have problems. You have to get representative values at the right time. 19C can help because what most of us do is this. As I said, we gather stats late at night, and the stats are perfect, and of course then the world starts, and we start doing things on our database, all those stats become immediately stale, and that's when everyone's doing all the work. It's like this absolute contradiction in terms. This is when I want everyone to use my system, but I can't because I'm gathering stats. This is when everyone does use my system, and now my stats are out of date. I'm sort of stuck. And then what happens is overnight we regather them, and they're all perfect again when no one's using the system. In 19C, what will happen is, as normal DML is occurring, we will apply updates to the statistics. We will actually have a thing called real-time stats. What happens is, as you make changes with normal inserts and updates, we will tweak the statistics in real time. It's not running a full gap. It's not like it's going to burn a hole in your server. We're simply saying, oh, you've added a row to a table, so num rows can go up by 1. You've added 10 rows to a table, so num rows can go up by 10. We just tweak the stats accordingly on stuff that we notice coming in. Similarly, every 15 minutes, we will go looking for stale stats and run a lightweight gathering process. It's like running gather stats, but not as CPU duty. So now in 19C, we have even normal DML will update the stats, and every 15 minutes, we'll go look for stale stats. So it tries to fix that problem of you had great stats 10 hours ago that now they're rubbish. Real-time stats are DML driven, and what we do is, obviously we can't every time you insert a row do a full gather stats. That would make no sense. What we do is we just do the cheap essential stuff. If you delete a row, we can drop the number of rows by 1. If you add a row, we can up that number of rows. If you've added, say, sysdate to a column, we know that we can up the high value for that column, etc. So nice simple things like sequence numbers, sysdate, kind of timestamp kind of stuff, we can actually keep record of the high and low values for columns and the number of rows in the table. It's a lightweight rapid gather. We use resource managers to make sure we don't consume your CPU. We're limited to a single core. The other thing we do to get you better statistics is in 11G, we have this concept of extended statistics, which is column groups. And it's to solve the thing what I call garbage in, garbage out. If I do, how many people are in Chennai in the country of Australia? The answer is obviously 0. We know that because there's a correlation between these two columns. I can't possibly have country of Australia, city of Chennai. In the same way I can't have city of Sydney and country of India. There's a correlation between those two columns. Now in 11G we introduced extended statistics to handle that. But in 12C we can do it automatically. We will actually monitor your queries and start looking for correlations between columns and therefore come up with extended statistics to improve on that. If you're not familiar with extended stats, so this is all feeling a bit new, come talk to me after. Extended stats have been around for a while, but we made it automatic in 12 too. In 12, we've also got a thing called expression tracking. If I run a query like this, it's a joint between products and sales, and I'm doing some stuff, and then I'm doing a standard deviation calculation. Well, that costs a lot of CPU. Standard deviations are a CPU-intensive process. So when I calculate this, it's important to me. I might want to calculate it every time I scan a row in the products table. Well, maybe I want to do my join first, and then just do the standard deviation on just this smaller result set. And that probably sounds more intelligent because that's an expensive thing in terms of CPU. Up until Oracle 12, we didn't know what an expensive operation was. We would simply say, what's the best way to optimize this join? And then once we've done the join, we might say, oh, maybe I'll run this first before the join. We didn't know because we didn't measure the cost of functions. In Oracle 12.2, we actually store, in a thing called expression statistics, we actually detect some of these expressions and we work out what the CPU cost is for them. And for example, if this one is very expensive, which standard deviations are, I will probably try to defer that as long as possible so I have the least number of rows to work on. For other expressions, it's much, much cheaper, like if it was just a simple subtraction, I could probably do that as I scan the products table, even before I did the join. So we have choices now because we track the cost of expressions. That was issue number 1. Issue number 2 is missing statistics. So we've hopefully covered all the poor statistics and things we've got there. Issue number 2 is if stats are just totally missing. Now we're going to struggle to get this done. The first one is online gathering, which is nice. The old problem is this. You're doing a huge insert from some enormous table. What happens when you run that? What's the first thing that happens? That's what happens. You stare at it. You've got coffee, it's still running, just home banking, it's still running. And then finally, 6 hours later, you've loaded to 7 billion rows. Which is great, but it's alleviated the worst things there is you're half done. Because then, you've got no stats on that object. You have to gather stats. If it takes 6 hours to load a table, rest assured, gathering of stats is going to take a really, really long time. Probably even longer, because we're doing huge amounts of calculations. In 12C, we have what we call on-direct load stats. And the reason I stress this is so many people still have these DMS stats calls after big loads, which they don't need anymore. I create a table, there's no rows in it obviously. I do an insert append, 76,000 rows, no DMS stats call, and we have stats there. When you do direct load operations, we will gather the stats as part of the direct load. So you don't have to do a follow-up call. So we halve the time. Some things to note. It must be a direct load. Insert append or create table is select. You can't conventional. If a conventional load, I get nothing. If you're on autonomous database on Oracle Cloud, even conventional loads actually have some statistics improvements in them, but that's another day. It must be empty. If I put even just one row in there and then do a direct load, guess what? We don't get the stats. So it's a specific task here. I'm loading data into an empty table in direct load. The execution plan tells you, you can actually see it says, I'm going to do a load, insert append, and I'm going to gather stats as I go. You can use the type called statistics, it will tell you, these are the kind of stats I did. It wasn't a stats gathered, it was actually stats I got as part of the load. 19C can help because even conventional DML can update the stats as we saw before. One thing that's important is we will not gather histograms as part of a statistics on load operation because we didn't want to slow it down. If it currently takes 5 hours to load a table, we couldn't come to you and say, guess what? You get stats now for free, but it takes 12 hours. So it still takes the exact same amount of time, and that's why we can't do histograms as we do the load. That would actually impact the performance. The third one is session global temporary tables. In 11G, this was the big problem with global temporary tables. I create a global temporary table, I put in 10,000 rows, I do gather stats, I do select T, and I get a perfect estimate. That looks great. Until someone else logs on. And of course, every session gets their own global temporary table. So his global temporary table is empty, but of course, the database still thinks he's got 10,000 rows. because the stats are stored for everybody. So one section put 10,000 rows in and gathered stats. Everyone else gets told we've got 10,000 rows as well, even though they obviously haven't. That's a problem. In 12 and above, let's redo the whole demo. This person creates a table, puts in 10,000 rows, gathers stats, they see 10,000. That's exactly what we want. Session number 2 comes along. They put in 50 rows, they gather stats, they see 50. That's what we want, that's cool, that solves that problem. If I go back to session 1, he still sees 10,000. It has been overwritten. In 12C and above, every session gets their own statistics for global temperature tables. And unlike most things in Oracle, when we introduce new features, we turn them off by default to keep backward compatibility. We didn't see any real benefit in terms of keeping the old behavior of global temperature tables because this wasn't any good. So by default, everyone gets their own statistics in 12C and above for global temperature tables. So far, we've covered listing of 4 statistics. We've got histograms, gather on low, apartment numbers, we improved the inputs, and margin C on our left. Issue number 3 in hopefully 5 minutes. No matter how good the stats are, I've got awesome histograms, I'm gathering them in real time every 15 minutes, I'm so excited, the plans are great. You still can't solve every optimizer problem because the number of stats you actually need for every query is infinite. There is not a finite number of stats you can calculate to optimize every single query. Sometimes you have to learn as we go. So for example, I have a query here which is find all the products with a unit price of 15 that give sold more than 1 unit. It looks like this, unit price of 15, more than 1 unit, and it's a join. There is no combination of stats that I currently have in any version of Oracle that can definitively optimize that query because it's a joint condition plus an inequality predicate plus an equality predicate. I can get good stats for that, but not for the rest. And in fact, the database thought there's 12. But what if there was 5,000? Yeah, that's a bad estimate. One of the things the database will do is, to quote Berkeley, is improvise, adapt, and overcome. It'll actually change the plan on the fly. So the plan originally was a nested loops because I'm thinking I'm only doing 12 rows. 12 rows will be 12 index scans. That's nice and that's a perfect nested loop. Of course, if there was 5,000, that would be a disaster. The runtime plan looks like hash join. So just to click back, the estimated plan, nested loops, when we actually started running it, it changed to a hash join. That is literally changing as you're running the query. That's called adaptive execution. Oh, this is This is what's called adaptive execution. As we're running, we learn as we run. We go, I'm expecting 12 rows. I've got 10 rows, I've got 11 rows, I've got 12 rows. I think I'm about to be done. Oh, there's a 13th row. Oh, there's a 14th row. And there's actually 2,000, 10,000. Lots and lots and lots of rows. The database can automatically flip from a nested loop to a hash join during the execution. You can see it in the middle of the SQL. It will say, is resolved adaptive plan. Did I change the plan literally during runtime of this query? I think that's a really cool option. It's a fantastic option. I call it dodging the bullet. It's like, I'm heading it this way, I'm going to drive this way, oh, traffic jam. I'll turn left and dodge around it. Yeah, that's what adaptive optimization at runtime is. It's like, I think this is going to be the best way. Oh, there's a million cars in front of me. I'll go left and get around it. That's changing at runtime. The second one we have is learning from our experience. I drive this way, there's a traffic jam. Tomorrow I drive this way, there's a traffic jam. Tomorrow I drive this way, there's a traffic jam. Next hour, I don't even bother driving this way. I'm going this way to start. I've learned from yesterday's problems, I'm going to choose a different path today. That's what this one is. This one says, here's my hash join. I expected to get 7,000 rows. I actually got 250. The next time I run it, it says it's re-optimizable. The next time I run it, it changed the estimate. So the stats haven't changed, but I still changed the estimate based on the previous feedback. So that one I thought originally 500 rows, I actually got 250. The next time I ran that query, I dynamically adjusted my estimate. That's also seems pretty cool, but we might have got carried away. If I think about it, traffic metaphor, if I go that way and it's bad, tomorrow I go this way. Well, this way might be bad, so tomorrow I might go that way, and then that's bad. Well, it's reasonable. I might go back to this way. Suddenly, every day is a brand new adventure. I don't have any. I'm not really learning anything. I'm just doing things at random. So what happens is this happens. People upgrade to 12.1, and every day the plans are different. And so DBA, that's not a fun place to be because you're constantly patching problems. You fix this problem, and it keeps coming back. So things weren't so good. That wasn't so great. Now, we actually have a lot more content to talk about, but I think that's a nice place to stop. Just to put your mind at ease, in 12.1, I will do a couple more slides. In 12.1, we had a single parameter which turned on both those things. This is changing on the fly during the query. It's a really cool thing. This is changing tomorrow based on today's results. It's a risky thing. And they were both turned on in 12.1 with one single parameter, which defaults to true. In 12.2, we got rid of that one parameter and split it into two. This one, changing at runtime, cool feature. This one, changing based on yesterday, more risky. And guess what we did? Default to true, default to false. So if you're on 12.1, go to 12.2. Or apply this patch to 12.1. And then you can get to that same split behavior. That's probably a better place to stop. So we had a lot more to talk about, but we had some problems with the projector. So thank you for your time. I'm around all day. Feel free to come chat. We can go through the rest of the slides if you're interested. But other than that, have a great rest of the day, and thanks for coming on.